Hello everyone, this video will give you a brief introduction to moment of inertia. As the name suggests, moment of inertia, moment is there itself here. So what is moment? We know that when a force is applied on the body, we can calculate the moment by multiplying the force with the perpendicular distance. As you can see, it is written here, it is the product of the force and the perpendicular distance of the point about which moment is to be calculated and the line of action of the force. You can see here, this is written here. So I am giving you an example how to calculate moment. Suppose the force of amount or magnitude F is applied at the point A and this is a point B. So AB is a bar or some section, and the distance between A to B is x. So when we are calculating the moment at point A, that is MA, it will be equals to 0, because the force itself is acting at the point A. So the distance will be 0, so the total moment will be 0 at point A. That is when we are calculating moment at point A. But when we calculate moment at point B, that is MB, there the perpendicular force or perpendicular distance between the point A and B is x, and the magnitude of the force is F. So the moment of a force F at point B, that is MB, equals to what? F into x, that is written here itself. Okay, this moment of a force is called fast moment of force. Simple thing, this moment of force is called fast moment of force. Next, when we multiply the distance x with the fast moment of force, that is, what is fast moment of force? This F into x. When you multiply the distance x again with the fast moment of force, it will give what? It will give second moment of force. It is clearly written here. The second moment of force equals to what? This is equals to moment of a force into distance x. Okay, so moment of a force equals to fx into x. It will give what? This will be f into x square, because distance is multiplied twice, so f into x square. Or simple, it is written here, when the moment of a force is again multiplied with distance x, it will give the moment of a force, means it will give second moment of a force. This second moment of force is briefly called as what? This is called as moment of inertia. Okay, clear? First of all, moment of a force means it is the perpendicular distance multiplied with the magnitude of the force. It is written here, that is moment of a force equals to fx. When I multiply again the distance with the moment of a force, it will give the second moment of force, that is also known as moment of inertia. Sometimes we calculate or we apply, instead of force we are using area or mass of the body. Simple thing, area of a cross section or mass of the body we are taking to calculate the moment or second moment. So while calculating or taking area as the area, the second moment is called as second moment of area or moment of inertia of area. I shortly writing moment of inertia as MOI in the video. Some part I will be writing like this. MOI means moment of inertia. Okay, similarly, when we are calculating or taking mass, it is known as second moment of mass. Simple. But our whole topic is basically based on second moment of area or moment of inertia of area. Okay, then we already studied in the centroid part. What is centroid? It is a point. How we calculate the centroid? It is given by x bar equals to summation of a x divided by summation of a. Okay, here also I told you first moment of force. Here it is first moment of force. The sometime first moment of force is also called as centroid, because here the first moment of force is called centroid when we use force, when we use area instead of force. Okay, because you can also see here what is first moment of force. When we apply force, it will f of x, f into x. Okay, but when we consider the area, what will it be? A into x, because instead of force we are using area, so it will be what? A into x. Fine, so it will give centroid. Okay, so first moment of force or first moment of area, remember first moment of area will give you centroid. Okay, so the unit of centroid is what? Meter or centimeter or millimeter. Already I told you. You can, I will give in the description part the introduction of the centroid. You can go through that videos if you are, if you have not seen those videos. Okay, so x bar, the unit, how it becomes meter, centimeter or millimeter. See, the unit of area is what? The unit of area is the unit of area. If you take it as meter, then it is meter square. Then x means the distance. When it is multiplied by distance, it becomes meter square into m. Then divided by summation of m, means area only. So this is meter square. So meter square cancelled out. It only remains meter. So the unit of centroid is basically in only meter or centimeter or millimeter. Okay, clear? Next, but the unit of moment of inertia or moment of inertia of area, basically here in this all videos we will be calculating moment of inertia of area. So you remember the unit for moment of inertia of area. Moment of inertia of area unit कौन होबो? सेठी मु पूर्वरु कहितली how to calculate second moment of inertia. Fx into x, means fx is the first moment, and when we multiply with x, it becomes second moment or moment of inertia. But instead of force we are taking area, so it becomes a into x square, or according to the distance we can write it as a into r square. Suppose here r is the distance from which the moment is to be calculated. Okay, so it becomes a r square. So what is the unit of area? It may be meter square, it may be centimeter square, or it may be millimeter square. So simple. Then meter square into r square means what is r or x? Distance. Distance square means it will become again meter square. Okay, so meter square into meter square, it becomes meter to the power 4 or centimeter to the power 4 or millimeter to the power 4. So unit of moment of inertia is the fourth power of the normal unit of length, means meter to the power 4 or centimeter to the power 4 or millimeter to the power 4 according to the question. Okay, simple. This is basic of moment of inertia. Then as I told you in the centroid part also, in fast videos I will basically go through the rectangular sections. So here also I am going through rectangular section. This is a rectangular section. Its length is denoted by b and height is denoted by h. So the x-axis and y-axis you can clearly see here. This is y-axis, this is x-axis. So the distance in x-axis or the length in x-axis is b, the height is h. So how to calculate the moment of inertia of this particular rectangular section? we are here basically calculating the moment of inertia about the centroidal axis of this section. Then already I told you in the centroid part, I will give the link in the description part how to calculate the centroid. If you don't go through those videos, you can easily see those videos and understand. So how to calculate the centroid of the rectangular part? It is basically length by 2. Here it is b, here it is b, so it becomes b by 2. Okay, here it is b, so it becomes what? B by 2. Similarly in y it is h by 2. Simple. Okay, so the centroid or centroidal axis will come like this. Here I have drawn, this is the centroidal axis. So the moment of inertia is calculated about the centroidal axis of a particular section. This is a simple rectangular section. एटा गोटे simple rectangular section. आमे moment of inertia कहा respect calculation करछंती centroidal axis of this rectangular section रो centroidal axis respect. ताको denote मो हिसाब रे मु लिखुची इटी IXX. तमे बहुत जगह रे बहुत नोटेशन पाई जीवो. सो कोडी कोडी लिखाई थे IJ ए वाला कोडी कोडी जगह लिखाई थे. ओके, बट the most important thing is remember that what is moment of inertia. The formula for moment of inertia for a rectangular section is very simple. It is base, it is what? Base into height cube divided by 12. Okay, simple. What is this? Base into height cube divided by 12. Okay, remember this because it will applicable for both axes, mean for x axis and y axis. Simple. Here I am calculating for x axis. For calculating in x axis, I will see in which direction. From like this I am seeing. So here what is base? It is base is what? B, or length of the base is what? B, and height is what? H. It is H. So the formula becomes base into height cube by 12. So IXX equals to B into HQ by 12. It is not coming directly, it is calculated through integration. So here for simplification I am directly giving you the formula. Remember this formula. Not don't mog it. Just remember this formula. What is the basic thing? Base into height cube by 12, that is B into HQ by 12 in the x direction. Okay, next I'll be calculating and follow the similar method, that is base into height cube by 12 for y axis also. Okay, in the y axis I will be seeing through which direction? In the x axis I am seeing through this direction, but in y axis I will see in which direction? From this direction. So from while showing from this direction, the base will be what? This will be the base, this will be the base. So what is the length of the base, or what is the distance of the base? This is h, this is also h. Okay, so base into, I already told you, base into height cube by 12. So base equals to what? H. Base equals to what? H. Height equals to what? B. So h into b cube divided by 12. Simple thing. For IXS it is b into h cube by 12. For IYY it is h into b cube by 12. Remember these two formula. Okay, this is very simple. B into h cube by 12, here h into b cube by 12, depend upon the question, but the method remains same. Sometime it is denoted by L, sometime it is denoted by D. So according to the formula, but method is same. Base into height cube by 12 depend upon in which direction in which axis we are calculating. आमे को axis रे calculation करचंती ता ऊपर depend करे. Okay, simple. Next. The next, because the question 2 mark question may be asked, or in OG it may asked on these simple problems to calculate the moment of inertia of a rectangular section, but for larger point of view it will ask the moment of inertia for composite section. Composite section means, already I told you, the L section, the I section, these are composite section because these sections are combination of more than one section. So these are called composite section. So for composite section, it will ask you questions on composite section. So how to calculate the moment of inertia of composite section? Don't worry, it is very simple. I will tell you in very simple manner. So just follow this. This is a theorem. What this theorem name is? Theorem of parallel axis. Exactly what this theorem tells: if the moment of inertia, you can see here, if the moment of inertia of a plane area about an axis through its center of gravity denoted by I-axis. Here also I calculated about the centroidal axis. This is the centroidal axis. This is the centroidal axis in x direction. So about x means I-axis equals to what? BHQ by 12. Here also written that about the centroidal axis of that particular area. So basically this formula is for that I-axis. Okay, this is telling about that only. This I-axis is nothing but that only. Okay, so then moment of inertia about any other axis, AB or CD. Here AB I have taken in here AB I have taken in x means for calculating x direction. CD I have taken for calculating in y. Okay, simple. So and the line AB or the axis AB is present at a distance of d from the center of gravity. From the center of gravity means from the center of gravity of this particular section. Okay, don't worry, very simple. The most important thing is here is that distance d, because the formula becomes what? IAB means moment of inertia about that particular line or axis AB is equals to what? IXX plus A into d square. What is A into d square? A is the area of that particular section into distance. What will be d? For this case, it is the distance from the centroidal axis of that section from the point A or from the line or axis AB. Simple. I am drawing here a rectangle. This is a rectangle. You can see this is the centroidal axis of the rectangle in x direction. Okay, so suppose the question asked to calculate the moment of inertia about, suppose the questioner asks to calculate the moment of inertia about this line. This line is denoted by AB. So AB. So this is very simple. This is a rectangular section. So we can easily calculate I-axis by using this formula. The dimension will be given in the problem. This dimension means this length and height will be given in the question. So very simple. Plus A into d square. What will be area? If this is B and this is H, so area will be what? Area equals to base into height. Simple, because this is a rectangular section. Combine na eta gote rectangular section. So area kete hobo? B into H. How I-axis kete hobo? Rectangular section ro centroidal axis respect re moment of inertia. Simple. Then important ଜିନିଷ ହେଲା ଏଠି କ'ଣ? D. What is D? D ହେଲା ଏଇ centroidal axis ର distance ଆମେ जो axis respect ରେ calculation କରିବା, କାହା respect ରେ calculation କରିବା? AB respect ରେ. ସେଇଠୁ ଏଇ centroidal axis ର distance କେତେ ହବ? ତ distance ଏଠି କ'ଣ? ଏଇଠୁ ଆର distance ଟା କେତେ? ଏଇ axis ରୁ ଏଇ axis ଭିତରର ଏଇ जो distance ଦେଖୁଛ, distance ଟା କେତେ? ୟାକୁ ହିଁ କୁହନ୍ତି D. So very simple. This is very simple. So I-axis plus A d square. If we are taking in y direction, means this is CD, so that will be changed into IYY plus A into d square. As this is a simple rectangular section, the area remains the same. Only change will be there in D, means distance. Okay, this is a rectangular section. Again I am telling you, this is y-axis and this is x-axis. This is x-axis, this is x and this is y. It is not the centroidal axis, it is normal coordinate axis, but the centroidal axis will be what? Centroidal axis will be somehow here. Okay. Okay. This is we denoted by, this is suppose xc, this is yc. Remember one thing, in centroid also I told you, when we are calculating x distance, we calculate it from what? Y axis. So this may be, this axis may be xc, but distance is what? Distance we are calculating, means axis we have drawn here, but how we draw the axis? We are calculating from this distance. So this distance is nothing but in y, which direction? This is y direction. So or from y axis, this is from x axis we are calculating the y distance. From x axis we are calculating the y distance. From y axis we will be calculating the x distance. So remember these two things. Next, this is a composite section, as already I told you, and already calculated the centroid of that L section. This is a simple L section. So the blue lines you are seeing, this is, suppose this is section 1, this is section 2. The blue lines you are seeing here is the centroidal axis of section 1 and 2. But the violet line, these violet lines you are seeing here, this is the centroidal axis of the whole section. So this theorem of parallel axis basically used to calculate the moment of inertia of that particular composite section about the centroidal axis of the whole section, because this violet line or purple line is the centroidal axis of the whole section. Simple. So this is I have shown you, this is also I have solved in centroid. This you can see, this is x1 means centroidal axis in x direction, this is x2 means centroidal axis in x direction. X1 means for section 1 and x2 means for section 2. Already told, x distance calculated from y axis. So while drawing or while calculating in x, we will be taking what? We will be taking the y distance, means this xc is the centroidal axis of the whole section, and this yc is the centroidal axis of the whole section. Okay, so simple. Already I have calculated, this is the dimension I have given for L section. This is 80, this is 20, this is 100, this is 20. So x1 is what? 40, because 80 divided by 2 40. Y1 is what? 20 divided by 2 10. Similarly x2 is what? 20 divided by 2 10, and yt is added with 20 because it is not, this section 2 is not touching the reference axis, so this distance is added here. Okay, so very simple. I will be giving you an example basis on this question. Okay, this is already solved. This question is already solved in the centroid video. Okay, so as I already told you, Ixs and Iyy calculation is very simple, and difficult is there calculating d. So very simple fundamental I will give you how to calculate this distance. So Ixc1, what is Ixc1? Ixc1 means the moment of inertia of section 1, the moment of inertia of section 1, which is section 1, this is section 1, or you can see here, this is section 1, the moment of inertia of section 1 in x direction about the centroidal axis of the whole section. This is the centroidal axis of the whole section, this is the centroidal axis, this is the centroidal axis for the section 1 in x direction. So as we are calculating for Ixx, so we will be considering these two centroidal axes, but the distance, but how to calculate Ixx1 plus a into d square. Ixx1 is what? as you can see here, ixx1 plus a1 into d square. So ixx1, it is 1. This is for section 1, so it is written 1. So ixx1 will be what? This section is 80, this is 20. So for section 1 we will be calculating the moment of inertia. Simple, bhq by 12 you can put here, bhq by 12. So this will be what? Base is 80, so it will be what? 80 into height is what? 20q divided by 12. This is nothing but this is ixx1. Okay, simple. Next, a1, as you are calculating for section 1, this is area will be become a1. So what is a1? This is 80 into 20 already. Therefore I always told you centroid or moment of inertia are mutually related to each other. So for calculating moment of inertia we have to study about centroid, or we have to calculate centroid. Okay, so simple. Next, the important thing is what? D. D means what? Distance. D माने कौन? Distance. कहाँ to कहाँ भितर distance? Distance है a section 1 रो x direction रो centroidal axis रो means x1 रो x भितर रो distance माने ए जो distance टा इटा केते हबो? ए distance टा केते हबो? जेतला हमें calculation करूचंदी ए जो particular distance टा केते? ए distance टा x axis इटा हमर x axis, इटा हमर x axis, इटा हमर y axis. ओके, इटा हमर y axis. तो जेते बेला हमें x axis रो मेजर करंती, को डिस्टेंस मेजर करंती? y रे डिस्टेंस. तो y रे डिस्टेंस माने मेजर करंती एटा कोन? x1 माने सेंट्रोइडल एक्सिस ऑफ सेक्शन 1. ओके, ताले डिस्टेंस टा कोन हबो? डिस्टेंस टा माने कोन? डिस्टेंस टा माने कोन हबो? डिस्टेंस माने हला y1. ओके, कोन पे ना x रो डिस्टेंस मेजर करले और x एक्सिस रो कार डिस्टेंस मेजर करंती y रो डिस्टेंस. तो ए जो x एक्सिस रो सेंट्रोइडल एक्सिस हला x1, from x axis we are calculating the from this x axis we are calculating the centroidal axis distance. ताले ए डिस्टेंस टा कोन हबो? x रो कैलकुलेशन करूचंदी डिस्टेंस x एक्सिस रो. तो सिंपल कोन हबो? डिस्टेंस y. तो y एटा जेहेतु सेक्शन 1 सेति पेंडा कोन हे जो y1. as you are calculating in from x axis, so it will that is distance becomes y, so this is y1. Simple. Similarly for section 2, when we are calculating, this is x2 and this is x2 from what? This x2 is calculated from this reference axis, because we have to draw reference axis. So this is also calculated from x axis. The distance will be what? Y. So remember, when we are calculating distance, this distance d, for x we have to take it y distance, means from for y distance is y1 and yc, that those things y1 y2 yc. So we have to take y distance because we are calculating moment of inertia in the x axis. So x axis means y distance. Okay, so this will become yc minus y1. Simple. You can see here, this is xc. This xc means from this to this. This is xc means what? From x axis to this distance. This is xc, or you can see here xc, this xc means what? This xc means what? From this to this distance, from this axis to this axis, this distance is what? Yc, nothing but yc, because we are calculating from x axis. So this is yc, this is y1, this distance is y1. So distance between, or I have written here, this distance will be what? Total distance. This total distance is yc and this small distance is y1 eliminated. So it becomes what? It becomes what? yc minus y1, and this as it is square, d square, so it is yc minus y1. Again I am showing here, this is the centroidal axis, this small distance is y1, we are calculating from this to this, so this distance becomes what? We are calculating from this to this, so this distance becomes what? Yc minus y1. Similarly for section 2, this will be this the distance d will be what? Similar. Ix2 plus A2 means for section 2 all becomes 2, so this will be A2 means for area for section 2. What is area section 2 रा कौन same 80 into 20 because 80 हमें divide कर दे चंदे तीटा part है section को, तो 100 to 20 गला रहिला के 80 into 20, so the area becomes 80 into 20. So similar D will be what, x axis distance y, so yc minus y2 2 because section 2. Similar thing for yc1 we are calculating iyy1. For iyy1 the formula same hbq by 12. Already told you the formula is what, hbq by 12. So basically we will be calculating for section 1 we will use that formula, means this distance is what, 80 into 20, so 80 into 20 the cube divided by 12, simple. Okay, next area will be what, for 1 the area will be 1 because I am calculating here 1, so area will be what, area A1. Then distance, as we are taking in y axis, so distance will be x, so xc minus x1. xc what, the centroid of the whole section, the centroid of the whole section. I am repeating continuously, मैं बारंबार कहूची yc और xc है centroid of the whole L section or the section given or whole composite section. So this is xc minus x1 square, for section 2 this is xc minus x2 square. तो ये जो xc minus x2 हो कि x2 minus xc हो किसी प्रॉब्लम नहीं, कौन पाई ना आमे एटी कौन कैलकुलेशन करूचंदी, स्क्वायर नहीं जानती, तो 5 प्रो स्क्वायर जहाँ माइनस 5 प्रो स्क्वायर भी से दीटा कर स्क्वायर कौन हम पॉजिटिव ही हम, कौन पाई ना 5 प्रो स्क्वायर कहते 25 से 25 से माइनस 5 प्रो स्क्वायर भी कहते 25, से सिंपल. नेक्स्ट I have simplified the formula to a shortcut manner. I means हमें जो calculation करिबा centroid of the particular section, एटी section number है I, हमें I माने 1 ही पारे 2 ही पारे, section 1 पाई हबो I equals to 1 हबो, section 2 पाई 2 हबो, तीनटा section तले 3 हबो, सेति पाई ता पारे, तो IXC1 IXCI equals to IXXI माने कौन, particular section रो ए rectangular जो ड्रॉ करथिली ए रेक्टेंगुलर सेक्शन रो निजर एक्सिस रेस्पेक्ट निज सेंट्रोइडल एक्सिस रेस्पेक्ट सेंट्रोइड केते हो बुझला, तो सेति पई IXXI प्लस AI I जा हितिबो 1 सबुथि पई सेम इनटू x एक्सिस माने डिस्टेंस कोन हबो y yc minus yi स्क्वायर. सिमिलरली IYCI equals to IYYY plus AI into xc minus xi स्क्वायर. ए दीटा फार्मूला मन रखितो. Remember this two formula, this will be most important or most you can say it like tips or shortcut tips for calculating moment of inertia using parallel axis theorem for any composite section. Okay, if you don't understand, you can, I will be giving an example or problem on I section in the next video. You can also go through and you can easily clear it out or ask me in the comment section. Okay, but this is the basic thing about moment of inertia. Okay, thank you.